In this video, we're going to look at solving quadratic equations by using the square root property. This is the first of two videos. In the second video, we're going to look at completing the square and then using the square root property. So this first page is a page of notes. We want to review the definition for a quadratic equation, which I have written here. Anything of the form ax squared plus bx plus c equal to 0, where a, b, and c are real numbers and the first coefficient should not be 0. Just keep in mind that quadratic means that the highest exponent, the degree of the polynomial, should be 2. So we have already seen how to solve a quadratic equation by factoring. But keep in mind that factoring doesn't work all the time because not every polynomial can be factored easily. So we also have the quadratic formula. This will work all the time. We also have the square root property, and then we have completing the square and then the square root property. So number 2 will work all the time, and completing the square works all the time as well. If you can't use the square root property, you will have to complete the square first and then use the square root property. Let's take a look at some examples. We would like to solve by using the square root property. One thing you want to notice about the first and the second example is that these are quadratic equations because the highest degree or highest exponent is 2. However, there is the middle term is not here. The middle term is missing. So notice that usually we have the bx term, this middle term, the x term. We don't have that for these two examples. So one thing to notice is that if you don't have the middle term, it'll be very easy to use the square root property. If you have the middle term here, you might need to complete the square first and then use the square root property. I will show you that in the second video. But for now, since I don't have the middle term, I'm going to show you how to use the square root property. The first thing you want to do is isolate x squared, which means add 169 to both sides of your equation. Once that's done, we take the square root of both sides of the equation. You want to keep in mind that when we take the square root of both sides of an equation, we need to include plus or minus because there will be two solutions. So we take the square root, I could just write that like this, and I'm going to put my plus minus on the right side because when we take the square root here, this is a perfect square, we're going to get plus or minus 13. So these are the two solutions. I can write them together like this, or if you want to separate them, you can write x is equal to 13, x is equal to negative 13. So you can separate them if you want. Either one is correct. Just let me quickly point out here that we could have also factored our problem. This is a difference of two squares. So if you were to factor, we would get x plus 13, x minus 13. And then we get the same two solutions. So this example, there were two ways to do the problem. We've already looked at factoring before, so this is just another method to get the same answer. You can, of course, use the quadratic formula as well, and you would get the same thing. The second example, 27 is not a perfect square, so we cannot factor this as a difference of two squares, which means that we should use the square root property. And we follow the same steps. Isolate x squared, add 27 to both sides. And then what we're going to do is the same thing square root both sides, but remember there will be two solutions, so we need to include plus minus. And this is not a perfect square, but I can simplify this. Remember that 27 is 9 times 3. We could take the square root of 9, right? So we're going to write plus or minus 3 square root of 3. And this is fine as a solution, or you can separate the two answers. Let's take a look at example 3. So example 3 and example 4 are a little bit different because they don't just have x squared. The part that is squared is a binomial. It's not just x. So I have a binomial squared, a binomial squared. That's okay as long as you have a binomial squared here by itself and it's isolated. I could automatically just take the square root of both sides. So if I were to square root both sides, I would get x minus 4 is equal to plus or minus square root of 36. So I basically did the same thing as number 1. Square root both sides, include plus or minus, and then 36 is a perfect square, so then I could just write x minus 4 is equal to 6. And remember, you do have to solve for x. Because the x is not isolated here, it's really x minus 4 instead of x squared, we have to solve for x. So you would just add 4. And when you do this, just make sure you keep the plus minus between the two numbers because we can actually calculate what the two answers are. One of them is 4 plus 6, so that's going to be 10. And the other one is going to be 4 minus 6, which gives us negative 2. So these are the two solutions in this case. You could have FOILed out the left side, set the problem equal to 0 and factored, and you would have gotten the same two answers. But instead of foiling and setting it equal to 0, it's much faster to just take the square root of both sides. Let's take a look at the fourth example. This is a similar problem as number 3. We have a binomial squared, but I have a 2 that's multiplied to the binomial. And what I want to do is I want to just isolate the part that's squared. We just want to get this part by itself. It's the same idea as getting x squared by itself. For number 3, we had the binomial isolated, but here what we can do is divide both sides by 2 and it'll make the problem the same as number 3. So we have an extra step. Once that's done, where you've gotten the binomial squared isolated, we can take the square root of both sides. So I can write that out, or I can just take the square root in my head, but let me just write it out here. Remember, you need plus minus. So we get x plus 3 is equal to plus or minus. I can simplify this. This is a complex number, so I can write it this way. And then once that's done, you have to solve for x. So I need to subtract 3. Just remember that when you subtract 3, you need to keep this plus minus between the two numbers. This is my final answer. I cannot combine negative 3 and I square root of 5 because they're not like terms. There are two solutions here, so just keep that in mind. Let me just write them out so you can understand. You can write them separately again. I can write them this way. Okay, those are the two answers. you could do that, or you could just write it this way with plus minus. Most of the time they're written with the plus minus just because it's easier to write it that way. And let's do two more examples. Okay, so remember I said that if you're going to use the square root property, you need to have just x squared without the middle term, or you could have a binomial squared isolated on one side. Well, number 5 does not look like the first two examples because it has the middle term, and it's not a binomial squared either. However, what you can do is you can look at this problem and we could actually factor it, and if we factor, we will get a binomial squared. So we can factor this as 2x plus 1 times 2x plus 1. And actually, let's not make this equal to 0. Let's make it equal to 12. I just noticed that I could factor, and when you factor, you get 2x plus 1 squared. And this is now a binomial squared. So we can just take the square root of both sides. And if we do that, and I can further simplify the square root. This is 4 times 3. So it's going to be plus or minus 2 square root of 3. And I still need to solve here for x. So we should subtract 1. Remember, when you're solving for x, this plus minus needs to be between the two terms, and we need to divide by 2. And these are the two solutions. So sometimes if you have a trinomial with all the terms, if you look at it, you might be able to factor. And when you factor, you get a binomial squared, and then we could take the square root of both sides. Example 6. This is a trinomial. However, this is not factorable, and I cannot factor it as I have here. So we cannot use the square root property here automatically. What you need to do is either use the quadratic formula to solve, or use completing the square first and then the square root property. So I'm going to put here, this is going to be our second video. We're going to start with this example. Since this is not factorable, we can't just factor it, and we also can't factor it so that we get a binomial squared. So we need to use completing the square. So we're going to see this in the second video. Just wanted to show you the difference between 5 and 6.